Hey guys, so I figured I'd get this out of the way now. Believe it or not, I think I actually covered everything I was supposed to in that lecture. So this video is like, it's kind of optional. I would maybe like stick around for the partial fractions note, but then the weird cases, you can kind of hold on to this till you get to the class in the fall, or if you are really just interested, you can just watch it through and check out the weird cases. But I'm not gonna really put it on my quizzes or exams, but you will most likely encounter this in the fall when you take the course. All right. So the one note I kind of wanted to talk about first is I wanted to bring up that example again, the one that we covered during lecture. I'll jump to the part where we were like solving for a and b. 7x minus 13 is equal to a times x plus 1 plus b times x minus 3. Carlos brought up like a point in class. He was like, oh, I did it this other way. I kind of want to show you guys the other way. I want to make sure that like I'm kind of covering all avenues here because, the method I showed in class was like really, it made sense to me, but for all I know, it may not make sense to you. So hopefully this method might be better for some of you. I don't really care which method you use. This method is a little bit more explicit when it comes to the whole like, the system of equation part. The one I showed in class wasn't really as explicit, but yeah, like I said, whatever method you want to choose, right? So this method it pertains to coefficients, okay? Because there's this math rule with coefficients. The two numbers you're going to pay attention to here are 7 and negative 13 because those are the coefficients of your terms, right? This is the like x term. And then like this is your c term, your constant term. So there's this rule in math that says if you line up the x terms with with the x terms on the other side of the equation, you can actually just set them equal to each other. And what I mean by that is if I distribute all this out, I get ax plus a plus bx minus 3b. And I can kind of collect my x terms, right? I can collect these together and it'll get me a plus b times x. And then I can collect my constant terms and get a minus 3b, right? And since it kind of lines up with the stuff on the other side of the equation, I can actually just set the two pieces equal to each other. I can set this a plus b equal to 7, and then I can set a minus 3b equal to negative 13. And what that's going to do is it actually ends up creating a system. A plus b equals 7, and then a minus 3b equals negative 13. And then I can just solve it from here. I could run a negative through this, and then and solve it that way. I get 4b is equal to 20, and we get b equals 4, which is what we got when we did the problem before. All right, so yeah, and then I'm sorry, and then plug it in to get a is equal to 3. So you can do it this way. Wait a minute, I think I messed up here. Whoops. B is 5. Sorry, I was rushing. B is 5, which means A is not 3. A should be 2. And that should line up with what we found in class, right? B was 5 and A was 2. So yeah, this is like another way if you want to do it, right? Like this is like, you see the system a lot more clear than the other method. If you like the other method where you do the whole choose your X thing, then you can do it that way too. Okay, so that's what I wanted to talk about with the partial fractions. Let's talk about the weird cases now. I just want to talk about two. There is a third one. I'll let you guys figure that out when you get to college. So the first example I wanted to talk about was where is it? Example 3 on page 444. That is the page, the PDF page, not the book page. Okay, so watch out for that. So this is integral of 3x minus 9 over x plus 2 squared x minus 1. So let's say you're given this scenario. You notice that there's actually a repeated linear factor. That's what they call this problem. a repeated linear factor. And what that means is, remember what I said, like we have to break up the fraction into the amount of factors there are. Right? In the first example, or the example that we did in class, there was only 2 pieces. But in this one, although it looks like there's only still 2 pieces, there's actually 3 factors here. Okay? The first factor being the easy one to spot, x minus 1. The second factor is going to be x plus 2. But then the third factor is actually going to be x plus 2 quantity squared. Right? Like if you want to think about it, like I know it's a little weird, but like if you want to think about it, if it was like 3 times like 4 squared, right? Or in this case, if it was what's 16 times 3? 48. So if your thing was 48, you got to break it down to like the factors that 48 could possibly be, right? So in this case, it's going to be 3, 4, and 4 squared. So like that, hopefully that kind of makes sense, right, into why we need to break it up into 3 pieces as opposed to 2. China will go through with you guys with how to go about a 3-piece partial fraction, but it's the same thing. You know, you're going to multiply everything by the common denominator, and then choose a good x value. Hopefully things will cancel out, and you just solve that way. All right, so I'm gonna just leave this to you guys if you want to do this. The trickiest part of this is just there are 3 factors to play with instead of just 2. All right, so definitely something you want to look out for in the fall. The next example 4. Oh yes, this one. They titled it long division. I'll do the long division part, but I'm not going to do the partial fraction part because, you know, hopefully at this point you guys know the partial fraction. So it's on page 445. Once again, this is the PDF page, not the actual book page. We're looking at integral of x cubed plus 1 over x squared minus 4 dx. You're looking at this and you're like, okay, well, I see that the bottom is going to break down into x plus 2 and x minus 2, right? But before you do that, the method of partial fractions actually only works when you are dealing with a fraction where the degree on the bottom is bigger than the top, right? And in all the problems that we assign you in this course and in the quiz and the exams, that's always going to be the case. But in the fall, that may not be so. So you have to, it's kind of like, okay, look out for it because it might happen. I don't know. It depends on how nice your professors are in the fall, right? So you have to note that the degree on the top is actually bigger than the degree on the bottom in this one. So what we're going to do first is actually do some long division to break down the fraction first. So it's interesting, right? So what does this mean? This means x squared minus 4, we're going to divide it into x cubed plus 1. And I know some of you don't know how to long divide, which is kind of weird to me. But yeah, this is how you long divide, right? You got to see what times x squared will get me x cubed. So I'm going to put that above it, and that's going to be x. I run this through, and I get x cubed minus 4x. I'm going to subtract that through. You get the x cubes cancel out, leaving you with a positive 4x. I drop the 1. And I think, yeah, so in this case now, right, this is going to be the remainder, right? So if I wanted to rewrite this guy, I get x plus 4x plus 1 over x squared minus 4, right? Because this is going to be the remainder. Oh, wait, no, sorry, I messed it up. This is going to be the divisor, and then this is the remainder. This is, I want to say either algebra 2 or pre-calc. You learn this. You learn how to divide polynomials. So, but yeah, and so this is the quotient, right? So it goes in an x amount of times plus the remainder 4x plus 1 over the divisor x squared plus 4. And this is the result of our original integrand, right? This came from x cubed plus 1 over x squared minus 4. And if we look at this, right, we just tack on the integral signs now. What are we left with? Well, I know how to integrate x. That's an easy one. That's just going to be x squared over 2. So that part's done. But now I'm left with the integral of 4x plus 1 over x squared minus 4. And you're like, oh snap, now I know I can break this up and use partial fractions on this part. Okay? So it was kind of like partial fractions with extra steps. That was a I hope you guys know the reference. Anyways, so yeah, it was in the beginning, right? We saw that it was a fraction. You needed long division to break it up, and then we saw the actual partial fractions part. I'm not going to do this in this video just for the sake of time. I'll let you guys do it. But that second part, you can use partial fractions. Don't forget your plus c. All right. So that's pretty much it. There is if you want to check out example 5, I mean, I can just talk about it. I really don't want to do it just because I don't want to confuse you guys anymore. But example 5 goes through 2 like examples. One that it's called irreducible, and the other one which is called, well, obviously reducible. Right? The first one looks like this, and then the second one looks like this. Just this one has a -9. So if you can see the letter B one, this x squared minus 9 is factorable. It can break down into this guy. Whoops, x plus 3, x minus 3. And in fact, there's going to be like a repeating factor. So actually this is going to break up into 3 pieces, and you should be able to carry out how we did in example 3. But you notice in example A, this 5A1, this one is not reducible. You can't break that down anymore. And when that happens, right, something weird happens. It's not going to break up into 2 pieces with an A and B. It's actually going to break up into something that looks like this. It's a little trickier. I think the idea behind it is just because this is because the x is being squared directly, it introduces this new like linear thing, like linear not constant, but linear thing that we have to kind of like take account for. Like I said, it gets a little confusing. Don't worry about it too much. I would maybe I think maybe this is covered in the fall, but not as harshly as maybe examples 3 and 4 that I did above here. All right, so that's it. I think it's a new record, 12 minutes. Once again, stay on top of your homework, stay on top of those assignments, and yeah, reach out if you need anything. I'll see you guys soon.